Hello and welcome back. Today we're going to be talking about solving equations, and we're going to be doing this in a more broad sense. So we're going to be talking about solving equations. And this is just our general method for solving equations. And this is actually in one variable, but the same sort of ideas will help us when we get to other types as well. So solving equations, we usually have three broad steps. Simplify. This is going to simplify each expression on each side. We're going to add or subtract. This is going to isolate our variable expression on one side. And last but not least, we're going to divide. And each of these things, really, we should talk about a little bit more. When we're simplifying, our goal here is to make sure that each side of our equation is simplified. We're going to have one other little thing that we can do to help us out, and that's going to be getting rid of fractions. But for now, we can do things like we can distribute. This is gonna clear parentheses. We can also do things like add or subtract our like terms. So we're going to combine like terms. And I'm going to put this out here just because it's useful. We're also going to do this. We're going to clear our fractions. Now I'm going to make a separate video just on this, but I'll give you at least one example here. We can clear fractions, and to do that we will use that least common denominator, that lowest common denominator. But we'll show you what that would look like. When we add or subtract, we've got two goals. We're going to isolate the variable term on one side. And incidentally, our constants on the opposite side. And last but not least, we divide. And we're going to divide by the coefficient. Let me get myself out of space here, including the sign. Now we always include that sign because we want to have our variable positive. It gets confusing if we do it any other way. When we include the sign there, it makes life much easier. And because positive divided by positive is positive, negative divided by negative, also positive. So we always include the sign when we divide. So let's go ahead and give us an example of what this looks like. And I'm going to start us out with something like this. Let's start out doing something like, I'm going to do a 3 times x minus 8 plus 4 is equal to 13. So our first goal here is we're going to try to simplify this side. I can't really simplify that 13, so I'm going to just sort of set that aside for now. But I can simplify this 3x minus 8 plus 4. And to do that, I'm going to distribute. So I only distribute into that set of parentheses. 3 times x is going to be 3x. 3 times 8 is going to be 24. So this is going to be 3x minus 24, and then plus 4 is equal to our 13. now what we can do is we can combine our like terms. Negative 24 plus 24, or plus 4, plus 24, is going to be minus 20. So it's going to be 3x minus 20 is equal to our 13. I can't simplify anything else all over here on the left anymore. So now I can move on to my add or subtract. I'm going to go ahead and add 20 to both sides. And when I do that, negative 20 plus 20 is 0, so this is going to be 3x plus 0, or just a 3x. And over here on the right, 13 plus 20 is going to be 33. Last but not least, we divide both sides by that coefficient of 3. Here we're including the sign is positive, so that's that. 3x divided by 3 is just x. Notice I'm not divided by 3x. If I divided by 3x, I'd be left with 1 over here, and I'd be left with an x in the denominator. Don't really want to do that. 33 divided by 3 is 11. And we're done. Nothing else is necessary here. Let's do another one. And we can do this with all kinds of things. One of the things that can be a little bit confusing for folks to start off with is what happens when you might have variables on both sides. If you've got a variable on either side of if you've got variables on both sides of your equal sign, it can be confusing. So let's take a look at what that might look like. For example, let's try something like, I'm going to do 5y minus 11 is equal to 2 times, oops, sorry, didn't want to do 2, I wanted to do 3. 3 times y plus 6. So over here on the left side of my equation, I can't simplify anything. But over here on the right, oh, we can certainly do that. I'm going to go ahead and distribute this. So I'll end up with 3y plus 18. Okay. And here we go, 5y minus 11. Our next goal is now to get all of our variables on one side. So I can also add or subtract my variable terms, not just constants. I could subtract 3y from both sides. Now, I don't have to move things to the left. I could have just as easily have subtracted 5y. The reason why I chose this is I knew that if I subtracted the 3y, I'd end up with a positive y term here. 5y minus 3y, when I add together these terms, is going to be 2y minus this 11 is equal to, looks like 18. Now I can go ahead and finish this up. I can add 11 to both sides. Now that's nice. My signs are going to work out nicely. So we'll have 2y is equal to, looks like we're going to have 29. And then when we divide, I always include the sign, and by doing this way, I didn't have to worry about dividing by a negative. Divide both sides by 2. And I've got y is equal to 29 halves. It is okay to have fractions. It is also preferable. I know some people are really tempted to say, well, why can't this just be 14.5? It depends on what you're doing later. I will also tell you that if I were dividing by a 3, you couldn't come up with you couldn't come up with an exact decimal approximation. So for now, keep it as fractions. Fractions are not your enemies. All right, I think that's all we're going to do for now. Oh wait, I did say we're going to show you at least one example before I move on of what it looks like to put fractions in here. So let's go ahead and show you what it looks like to include some fractions. Let's say we've got something like 3/4 x plus 1/2 is equal to 5/8. And this looks dreadful, doesn't it? But here's the thing. If I were thinking about this, if I remember what I said, that if we multiply both sides by the same thing, it remains the same equation. Everything stays valid. So what I'm going to do here is I'm going to take a look and see what I can multiply by that will make all of these fractions go away. So what we're going to do is we're going to find the LCD of all of the fractions. And here I'd have to say it's going to be 8. Between 4 and 2 it would be 4. Between 4 and 8 it would be 8. So I'm just going to multiply both sides by 8. So what's going to happen now is I multiply both sides of this equation by 8, and something really cool happens. I've got 3/4 x plus my 1/2 is equal to that 5/8. So when I multiply both sides of this equation by 8, you might think that, well, I mean, over here on the right, it's really obvious. 8 goes into 8 one time. Or I could think about this as 8/1 if you want. And this is just, I'll be just left with a 5 here. But on this side, I need to distribute this. So that's going to be times 8, and that 1/2 is also times 8. And because it's a common denominator, I can just directly divide that denominator into that number. 4 goes into 8 2 times, so this is going to be 2 times 3x is 6x. 2 goes into 8 4 times, so 4 times 1 is 4. Now I can directly solve this, and this probably looks a lot friendlier than our original one. I'll go ahead and subtract 4 from both sides now. I've got 6x is equal to 1, and now I can divide both sides by 6. So I've got x is equal to 1/6, and this would be a large, this is actually an infinitely repeating decimal, so don't even try to do a decimal. But there's our answer. Alrighty, that's all we have for now, and I will catch you in the next video.